Hello everyone. Today I'll be presenting my final project for the Big Data Analytics class called Graph Visualization and PageRank of the Yelp Social Recommender Network. The motivation behind this project is the sheer volume and understanding of the Yelp data. As of quarter 3 of 2016, Yelp has over 115 million reviews and over 174 million unique visitors per month according to Google Analytics. For example, one restaurant, Mon Ami Gavi in Las Vegas, has over 6,300 reviews. Manually scanning these reviews just doesn't scale when you consider multiple businesses in a certain area. Previous work on the Yelp Academic Dataset includes review text sentiment analysis that uses LDA or modified LDA to extract topics and subtopics from the reviews, restaurant recommendations using machine learning techniques, and there have been some visualizations that use word clouds to look at the subtopics from LDA, some circle graphs, and some heat maps that look at the geographical location of these reviews. However, none of these visualizations show the connection between businesses and users as a large network. My current work will be to create this visualization of the network graph between businesses and users and hopefully show how these users and businesses are connected, and then thereby help the businesses identify consumer influence. Businesses can also use this type of graph to identify business competition, and users can use it to identify business popularity. It's much easier to look at a graph than to read a big data table, and definitely much easier than manually scanning thousands and thousands of reviews. And here's an overview of the system. First, I got the academic data set from Yelp here. Now, these files were in JSON format, and the IBM System G visualizer requires data in CSV format. So we had to do some data cleaning and extraction. And to do that, I used R, Python, and Bash to create my vertex and edge files. And once those are prepared, I loaded into the IBM System G native graph store. Using G shell, I run the PageRank algorithm to determine the influence and popularity of each business. And then finally, I load that all into the IBM System G visualizer to get my network graph. Now all of this is hosted on Ubuntu, running on the Amazon Web Service EC2 service. So let's look at what the raw data looks like. The raw data contains just about 2.7 million reviews and 648,000 tips about 86,000 businesses across 10 cities, all by 687,000 users. Now the dataset does also have edges between these users, which user is a friend of whom, and that is a total of 4.2 million social edges. The total size of this dataset is 2.62 gigabytes. Looking at the format, now this is just a general overview of the format of the data structure. For the users, we have the user ID, the type, the name, the review count, how many reviews the user has written in the entirety of the account, average stars, Yelping since, so the date that they joined the Yelp, number of fans, votes, and friends list. So this is the social edges right here with the friends list. Now the other vertex would be businesses. Now each business has business ID, type, name, city, state, the geographical location, number of stars, and review count, and an assortment of other attributes. If it's a hair salon, it might be what type of hair cuts that the salon specializes in. If it's a restaurant, maybe category of food. And for the edge files, I used the reviews. It's got the type, business ID, the user ID. So here, this is where we're going to make the source and the edges. The source of the edge is the user ID, so the user that conducted the review. the target of that edge would be the business ID over here. Also the stars, the review text, data review, and the votes. Let's go look at the actual data. So here I've created some shorter files so we can open them. The files for the reviews are actually so big that Notepad++ can't even open the file. You have to use head in Linux to look at it. Here you can see that it's a nested JSON file. So each row is an individual business. And within each row you can have the tags over here, the value, the tag, the value, and so forth. This is the business file. Now for the user file, the same thing. Nested JSON file. So each row is a separate user. See, user IDs over here, name over here. And again, the same thing with the reviews. Right. Now, one of the things that I had difficulty with was the conversion from these JSON files to the CSV files, because these special characters are not handled very well, right, by the Python script that was provided by Yelp originally. So let's look at that. Here we have the script that Yelp provided to convert JSON to CSV. It does okay with most of the files. For example, the user file doesn't have any problems at all. However, in the review files, sometimes with the escape characters, it will output an error. So instead of using just this Python script, I had to go and use R as well. All of my scripts are hosted at this GitHub link over here. Let's go look at one of the R scripts. For the user file, as I said, for the user file, the Python script works great. So I used the Python script to create a CSV file of the users, and then use R to select the columns that I want and organize it into a data frame and output it into the Vertex user files. Now, for the business files, that's a little different. The business files, I actually stream in JSON file, replace some of the new lines over here, the special characters, in the address, so that when it comes out in the CSV file, it's all one line. For the reviews, the same thing. Stream it in as a JSON file, convert it to a data frame, and then output as a CSV. Now, one disadvantage of using R is this operation over here loads the entire file into memory, and then R operates on it. So now you have one copy of it in memory and another copy of it in memory because of this data frame. So if you don't have enough RAM to store almost double your data, then you're going to have a RAM issue. So you have to make sure that you have enough RAM for the size of the data that you're dealing with. And that's why I actually had to cut the number of reviews down from 2.7 to 1 million so I can execute this command over here in one run. And after running those, we get CSV files. This is the business CSV file. You see business ID, type, name, etc. With an IBM System G Graph Store, you have to put the ID first. So here we have the ID first. Again, with the user, ID first. User, name, all the things that we're looking at. For the reviews, we do source, target, the type of the edge, here review. So you can see it's all nice and done in the CSV file. Now to create our graphs, and go back to the code over here, we will use the G shell scripts that I've stored over here. In G shell, to start it, you can go to your root folder for IBM System G. Now there's two ways to start G shell. You can do G shell as like an REPL, like this. Right, then you have G shell. You can type your commands. For example, it's not a command. There we go. You can type your commands like that, or you can do G shell interactive and then some commands .g and load a command from a file in that way. Now I already created the graph, so I'm not going to go through and do that, but just to show you how to run that. With the graph create script over here, that creates the full Yelp network store. So that's all 770,000 nodes and businesses and users, and over 1 million edges. So that combines all of that, loads that all in, and creates the graph store. The visualizer cannot render that many nodes and edges. I mean, it's not reasonable on a 1080p screen, even if it could render that. So what we have to do is we have to create some subgraphs using these two scripts over here. The first example subgraph that I created, I called Yelp Pop. It's a graph of businesses with review counts greater than 1,000. So what happens here is it opens up the Yelp full native store, filters it according to this condition, does some analytics, does some massaging to get a good graph that we can visualize, outputs it into CSV files that we can use again to create the subgraph over here. So yeah, I'm creating the Yelp Pop store. I'm loading in my CSV vertices that I created up here. I load in my CSV edges that I create up here. And then I start my analytic engine and I do my PageRank algorithm over here. I do the same thing with another graph called my Yelp Pit, which is all businesses in Pittsburgh with review counts greater than 100, along with associated users that review them. Again, open up my Yelp full store. I create my CSV file for my edges and my vertices. I close that store. I create my new graph, Yelp Pit, and load in those two and do the same operations as before. Some PageRank, some filtering. So let's look at what these end up like. Here is the visualizer for the Yelp Pop graph. I'll show you the GUI as well. This is the GUI of the visualizer. As you can see, it runs on the web browser. So that's one of the constraints of this visualizer Lite. Since it runs on the web browser, there's a limit to how much it can load, right, due to the web browser constraints. So I found that through trial and error, it can comfortably load in a subgraph with about 9,000 nodes and 20,000 edges comfortably. And that's about the size of this graph, well, not visualized over here, but in the store. So see, if we set the node size mapping to be our PageRank, we can see the different nodes and how influential and how important these nodes are. Right, Mon Ami Gabi, the French restaurant we talked about earlier, 6,000 reviews right over here. Compared to some of the other, well, all these are pretty well known because they're greater than 1,000 review. But let's say Firefly over here, it doesn't have as many reviews. The node is a little smaller. Now there is a difference between using the review count and using the PageRank, because if we think about it, let's say this person over here, Ashley, even though Ashley can review multiple number of businesses, Ashley can only be in one business at the same time, right? So by using PageRank, not only are we giving an indication of how many times the restaurant has been reviewed, it also gives us a relative probability of someone ending up at these businesses. it's only relative because in this graph, all the user nodes actually have a page rank either. So the only useful page rank currently is for the businesses. And if we want to look at it, you can say, okay, this node has a greater page rank than this node, so this node is more likely to have more people in it. But the absolute value of the page rank doesn't have as much use at the moment, unless we normalize it by the total of the page ranks across just business nodes. Later on in the future, I hope to incorporate the social edges between users as well, and that will give a better picture of how influential each business is and how influential each user is as well. Then the page rank of the users will matter a little more. Now if I perform this type of analysis, okay, with the page rank on a number of businesses that are located in one city, let's say Pittsburgh, then I can actually get a geographically constrained idea of what businesses are more influential and less influential in that immediate area. This could be really useful for someone who's in Pittsburgh, has a business in Pittsburgh, and wants to identify some business competition. Instead of going through and reading reviews about businesses in my space, I can look at this graph and say, okay, if I'm this node, Piper's Pub, are there nodes that are bigger than me that maybe I should look at as far as competition is concerned? It's much faster for someone to pull up a graph like this, go, okay, this is an influential node, this is an influential node, than to go through the reviews and go through the star ratings one by one. I can even do the same thing and put the star ratings on here. So this is just businesses in Pittsburgh. I can tell, okay, how many businesses have 4-star. I don't have to scroll through a table. I can just look at it visually and just get an idea very, very quickly. Let's go back over here. So in conclusion, I've created graph visualizations of the Yelp businesses and users. The edges show the connection between these users and the businesses. And I've used PageRank to show the popularity of the business. In the future, I hope to incorporate user-to-user edges, the social edges, so that I can identify the source of the influence in my graph. Now, something else I'd like to do is include sentiment analysis into the edges and then run reverse PageRank on it to hopefully see if we can find the origin of certain sentiments towards some restaurants. Well, that's my project, and thank you for listening.